We are live. We are live now. We are live. Hello, Sasyakal, Adab, Assalamu alaikum. So, my dear students, we are live now. Yes, अभी हम live आ चुके हैं. So, if you are watching me, do tell me the quality of the broadcast that you are having. Quality of the broadcast. Like कैसी ऑडियो आ रही है, हाउस द क्वालिटी ऑफ द ऑडियो, हाउस द क्वालिटी ऑफ द वीडियो. ओके, दिख रहा हूं ना मैं? तो यू कैन रेट इट फ्रॉम बिटवीन वन मीन लेस, वन मीन वोस्ट, वन मीन बेकार, एंड 10 मीन ग्रेट्स, एक्सीलेंट, एंड where's the pen, where's the pen, where's the pen, where's the pen? Oh. So you can rate it between from 1 to 10. 1 from bad, 1 for bad, 2 10 for good, 1 for bad, 10 for good. Yes. And now my dear student who are watching, do tell me how's the preparation of the exam going on. अरे भैया तैयारी कैसे चल रही है आपकी? तैयारी कर रहे हो ना? 1 for bad, 2 okayish, 3rd good, 1 bad, 2 okayish, 3 good, 1 2 3. You can rate it from between 1 to 3. 1 bad. If you are bad, we will make your preparation good. Okay. And 2 so like okay, I will score around 500. And 3 and 3 and 3 and 3 and 3, I will score around 600 plus. So 1 2 3, rate it from between 1 to 3. Okay, if you are 1, we will make sure that you reach 3. If you are 2, we will make sure you reach 3. And if you are on 3, I will make sure that you will become topper. Okay, 1 2 3, 1 2 3. Okay, after that, you know the topic, you have come here. Topic का नाम देख के तो आप आए हो. You have know the topic. Today we are gonna start the what? Atoms. We're gonna start the atoms chapter. Pretty easy chapter, scoring chapter. So make sure that you stick to this chapter and can मतलब पढ़ो यार, आसान चैप्टर आपको आना चाहिए. So atoms is what we are going to do right now, right here. So let's get started. Yes. So let me tell you about myself. So myself, yes, atoms. Yes, Nidhi Kumari, we are going to do atoms right now. So myself, Raghav Sharma, has an experience of 3+ years of NEET teaching in physics. Physics, the NEET students which are scared of, I think it is the most easy subjects in, I think it is more easy than biology itself. It is my thought. MSc Physics, BSc Physics Honors, B.Ed from MDU, and has done some research work in JNU and published an international article in Journal of the American Ceramic Society. This is about me. You know that I know things. So our goal for today, you and me, what आज हम मिलके क्या करेंगे? आवर गोल समझते हो ना? आवर गोल होता है आवर गोल. This is what you and me are going to do today. You and me मिलके करेंगे. So first Dalton atomic model, then Thomson Rutherford experiment, and observation analysis of Rutherford experiment. Decision process, there will be lot of things that you are going to do today. Good noon sir. Good noon, good. Tanya, Anya, what are you writing? Go noon, sir. What is this? What is this? So, so before starting, make sure that you are following us on our what channel on Telegram. Channel name is AltNEET, ALT in which we provide you PDF material, free PDF material, where when we will complete something in YouTube, then we share some PDF material, free classes, announcements, giveaways, prizes, discounts. So there are many announcements that you can get. Many students has taken our paid free subscription by just joining us on the AltNEET. So we do various thing on the where on Telegram. भाई बहुत चीज करते हैं हम Telegram पे, तो make sure you are there. And if you are in Instagram, okay, if you are in Instagram, we are also in Instagram. So make sure you are there too. Make sure you are there too in Instagram. Okay, Instagram link is this. Just write Altedemy and you can find us. Okay, yes, we are starting with the. So fast. So what is happening? There are various models for structure for atom that you are gonna study. Dalton, Thomson, Rutherford, and Bohr. So today we are going to cover Dalton, Thomson, and Rutherford. These three we are going to do today. Have any one of you know what is atom? Sorry, what is model? What is model actually? What is model? And why it is called model? Why it is called model? So model. Let me write definition. Okay, let me write a definition. A model. Where is this thing? Oh, where is gone pointer? Where is the pointer? Pointer, come. Some issues. So let me write a model. Writing is bad with this. A model is what is a model? A model is a set of hypotheses. I think something is wrong with this writing pad. A model is a set of hypotheses based on logical and scientific facts This is a definition of what is actually is model. भाई model क्या होता है? जैसे हमने कुछ थ्योरी दी, we have given some theories, done some experiments and done some lots of experimental verification. Okay, what we have done? We have done some experimental verification. We have given some theories. कुछ theories दी हमने, कुछ हमने experimental verification करी. And जो मॉडल उन theories को satisfy कर जाए. Okay, the model which satisfy these theories, called what? Called model of an atom. So in syllabus there are 4 models here. Dalton, very first model was given by Dalton. The very first model given by whom? The Dalton. After this, second model is given by Thomson, third model is given by Rutherford, and fourth model was given by Bohr. In your syllabus, Rutherford and Bohr are the important ones. In your syllabus, Rutherford and Bohr are important ones. So this is the Dalton atomic model. So what does Dalton said? He said every No, there is something wrong with the writing pad. So make sure you are sitting with pen and paper, because I am going to dictate you. What is Dalton's atomic model? Dalton said every model is made up of tiny individual particles. Okay, made of what? Tiny individual particles, and what we call them? We call them atoms. Every element is made of tiny individual particles called atoms. Atoms of same element. Okay, these things we have already known in chemistry too. Atoms of same element, जो atoms होते हैं same element के, are identical in what? Identical in both physical and chemical properties. Same in physical and chemical properties. This what Dalton said. This means that there is an atom of some particle here in earth, and there is some particle of some atom, in moon. So if they are of the same element, they are going to be ditto in both physical and chemical properties. Okay. And another thing he said that atoms are neutral. They don't have any positive charge, they don't have any negative charge. They are what? They are neutral. They are neutral like this. This is the Dalton's atomic model. They are like the spherical balls. Okay, got it, my dear friends? Got it. What was the reason that this atomic model failed? कुछ तो वजह रही होंगी जो ये कामयाब नहीं हो पाया. कुछ तो वजह होंगी जो ये कामयाब नहीं हो पाया. Okay, what was the reason for that? Okay, in 1897 there was a discovery of electron. Okay, electron gets discovered. जज्बात बदल दिए इलेक्ट्रॉन ने. तो what does Dalton said? Dalton said that atom is what? Neutral, no negative, no positive. This is neutral ball. But there was the discovery of electron. अब ये इलेक्ट्रॉन आ गया. So atom can be divided in subparticles. Or Dalton said for this, no. It is the what? It is the building block. It cannot be divided. But what we have found? We found electron. Thomson sir found electron. He said, no, Dalton, you are wrong, buddy. Dalton, you are wrong. खुशी, हेलो, आपसे मिलके खुशी हुई. Hi sir, poetry by Tarun. Hi Tarun, how are you, buddy? After this, what happened? Thomson model came. After this, what? Thomson model came in 1897. Another model came in 1897, or this model's another name was, as you already know, plum pudding model. Model. Funny name. Plum pudding model. Funny name. Plum pudding model. So what he said. Order. So he said atom. Saf. Oh, Saf. Hello, sir. Good afternoon, Saf. So he said atom is a positively solid. He said atom is a what? Atom is a positively charged solid sphere. Atom is what? Positively charged solid sphere in which electron are embedded. In which electron are embedded. What he said? Atom is a positively charged. Atom is a positively charged solid sphere. Positively charged solid sphere in which electrons are embedded like this. These are the electrons that are embedded in it, like the watermelon. Hello, hi sir, I'm from Kashmir. I like your way of teaching. Thank you, Arusha Mir. Thank you, thank you, thank you, thank you, thank you. So he said what? Atoms is a positively charged sphere and electrons are embedded in it, and its radius, this is the sphere. He said this is sphere, and if it is sphere, it will have some radius. It will have some radius, and the radius of the said sphere is in the order of 10 raised to minus 10 meter. 10 raised to minus 10 meter. Okay, the order of the radius of this sphere. He said atom as a whole. Atom as a whole, okay, not has a, is has a, has atom as a whole is neutral. Atom as a whole is neutral. Atom as a whole is a neutral. Okay, he said it is a neutral as a whole. He said it is a neutral as a whole, but it is made up of what? Positive and negative part. Positive part is what? The atom itself, it is positive, and electrons are embedded. Okay, this is the only thing the Thomson added. And why this model failed? कुछ तो वजह रही होंगी, जो हमने इसको नकार दिया. What are the reasons that this atomic model failed? Okay, this model failed. It can't explain it. It was unable to explain Rutherford scattering experiment. It was unable to explain Rutherford scattering experiment. Okay, this we will do, okay, right now in today's class. It was unable to explain Rutherford scattering experiment. And second, it could not explain the line spectrum of hydrogen atom. Okay, line spectrum hydrogen atom. Line spectrum of hydrogen atom, we will do it tomorrow. And Rutherford scattering experiment, this is the thing that we will do today. Okay, this is today. Okay, this is today. Today we will do it. Rutherford scattering experiment, and tomorrow we will do line spectrum of hydrogen atom. Okay, line spectrum of hydrogen atom. And there are some achievements of the Thomson models also. Okay, what does it is achieved? Okay, what does it achieved? Achievement, let's say achievements of Thomson model. What does it achieve? उसने क्या साबित करके दिखाया जो डाल्टन नहीं कर पाया? Okay, it explained first thermoionic emission. What is this? When we heat up the metal, there are the emission of electrons. So this thing, so by the Thomson atomic model we can explain thermoionic emission. Second, we can explain photoelectric emission, and we can also explain ionization of electron. So कुछ तो करा है इसने. It explained thermoionic emission, photoelectric emission, ionization, but it wasn't able to explain the Rutherford scattering experiment and the line spectrum of hydrogen atom. Cool. Yes. And my dear friends, make sure you are subscribed. Make sure you are subscribed to our channel on YouTube. Make sure you are subscribed to our channel in YouTube, where you can get daily live lectures and notifications and what is actually going on. Okay, we will also put some motivation for you. Okay, cool. Now let's move on and let's come to the Rutherford experiment. And what was the Rutherford experiment? Okay, what was the Rutherford experiment? Let's do it. In 1911, okay, there is a timeline. Dalton, then there was Thomson, and now there are Rutherford. After this, in timeline, there will be whom? Bohr. So there is a timeline. First he came, then he, then he. Okay. So I am teaching you by the timeline. So in 1911, there were two scientists. H. Geiger. Okay, Geiger. H. Geiger, and another was Ernst Marsadine. Okay, Ernst Marsadine. Marsden. Okay. So these two scientists, sorry for the writing, in 1911, H. Geiger and Ernst Marsadine, okay, these two conducted the experiment that was called as Rutherford experiment. Okay, Rutherford actually didn't done his own experiment. These two scientists, H. Geiger and Ernst Marsadine, conducted the experiment, and that was called as alpha scattering experiment. Alpha scattering experiment. Okay, in which what is happening, there is a lead box. This is a lead box. Okay, this is a lead box. LEDBOX. This is the lead box. In lead box, there is a source of alpha particle, or you can say some radioactive particle. Some radioactive material is in the lead box. Okay, lead box, and there is some what? Radioactive material. There is some radioactive material, and here there are some collimator. Okay, and because of this collimator, we are creating a fine beam. Because of the collimator, we are making a fine beam of what? Alpha particles. We are having a what? Fine beam of alpha particles. Beam of particles. Which type of particles, my dear friends? Alpha particles. We are getting a beam of alpha particles, and this is a thin gold foil. So this is a thin gold foil, super thin. This is super thin. Okay, made in some research labs in with so much efforts. Very thin sheet of gold. So there is a lead box. In lead box में क्या है? In lead box there are radioactive materials which are emitting what? Which are emitting alpha particles, which are emitting alpha particles. With the help of collimator, we are having a fine beam of alpha particles that are striking the thin gold foil, that are falling in thin gold foil. And after hitting the thin gold foil, some are going here, some are going there, some are going there, some are going there, some are going there. Okay, so in this thing, there is a detector, there is a detector, there is a detector, there is a detector which is measuring how much alpha particles, striking here, striking there, strike here, how much particles are striking here and there, how much alpha particles are striking here and there. So this is the Rutherford experiment conducted by H. Geiger and Ernst Marsadane. Okay, Marsadane. Yeah, nice name. Okay. So my dear friends, what are the observation? Okay, we have conducted the experiment कर लिया, done. Now what are the observation? What does those two those two scientists see in the experiment? What are they see? They have seen, first point, okay, make sure you are sitting with pen and paper. So what does they see? Most of the alpha particles, are undeviated, are undeviated. How much? 99.8% of the alpha particles, go undeviated, like there is nothing, there is no gold foil, there is nothing here. तू था भी यहाँ. So 99.8% of the alpha particles goes undeviated. From, if you compare, in thousands, only 2 alpha particles deviated. This is the ratio. Good afternoon, sir. Krishna Gopal. Good afternoon. Radhe Radhe. Okay. Second points they seen. Only 0.14%. Only 0.14% of alpha particles deviated more than 1 degree. Only 0.14% are deviating more than 1%. 1 degree, okay, not 1%. Only this much percentage of the particles are deviating more than 1 degree. 1 degree. Okay. Third point is what? 1 in 8,000 alpha particles deviated more than 90 degree. 1 in 8,000. Okay, only 1 in 8,000 is deviating more than 90 degree. Okay. Fourth point. Okay, I think I don't have to exaggerate that. And 1 in 10 lakh. Okay. 1 in 10 lakh. Okay, or you can say 1 in a million. There is a song, I think, in English somewhere, 1 in a million of alpha particles deviate by 180 degree. Okay, deviate by 180 degree, 1 in a million. You know, the way he goes, the way he coming back, 1 in a million. Okay, so these are the observation seen by the Geiger and what was his name? Marsden in Rutherford scattering experiment. Rutherford scattering experiment. Okay. So as you can see, this is the graph. For better understanding. This is the graph for the better understanding. So this is the scattering angle: 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, and it is coming exponentially down. It is coming exponentially down. This is the graph. How much particles are scattering in this thing, this thing. Okay. And we can write it mathematically. And mathematical formula is important for you. Number of alpha particles scattered at an angle theta. How to put that in formula? So n is equal to, okay, make sure you are sitting with pen and paper. This is actually also in the CBSE too. kz square sine 4 theta by 2. If you put the value in this thing, you will get, okay, if you want to find and the theta 90, just put the value of 90. Sine 45 raised to 4, put the value of k. What is k? K is constant. For some given material. Okay, for some given material. This value, this k can vary for different particles. Okay, this k here is for gold. Gold coil in Rutherford experiment. Okay, this depend upon the material, or you can say foil. K is this. Z is what? Atomic number of foil. In this case, what it will be? Atomic number of gold. And theta, you can just, what is theta? The angle which you want to find the number of materials. So put the value in this thing and you will get how many particles are coming at various angle. So from here we can see n is inversely proportional to the sine raised to 4 theta by 2. Okay, and inversely proportional to 1 raised to sine raised to 4 theta by 2. Okay. Now my dear friends, and now we have seen the observation. Now what is the analysis? क्या चीज निकल के आई? What are the analysis? What did they find after doing this experiment? What are the new observation? They have seen the observation. Now what is the analysis of this model? First thing, since most of the alpha particles are undeviated, how much? 99.8% of the alpha particles are undeviated. are undeviated. So we can say most of the part of the atom, okay, most of the part of the atom is empty. Okay, most of the part of the atom is empty, is empty. Most of the part is empty. Most of the part is empty, not some spherical ball said by Thomson and Dalton. That is not like a watermelon. Okay, there is so much free space. There is so much free space in atom, and that thing is hollow. Okay, atom is hollow from inside. Atom is hollow from inside. Okay, this is the hollow part. Hollow part. Got it? Got it? Got it? Got it? Got it? Got it? Okay. So this is the first analysis that is came from the Rutherford nuclear model of atom. खाली है, free space. There is so much free space inside the atom. There is so much free space inside the atom. Okay. Since and after the second thing that we have seen, only some alpha particles are deflected by more than 1%. How much? Only 0.14%. This mean what? This mean what? This mean what? That positive charge is concentrated in an extremely small space. In an extremely small space inside the nucleus. सारा तो खाली पड़ा है. And only very little amount of alpha particles are getting deflected. Only 0.14%. So we can say that the mass of the nucleus, and the positive charge of the nucleus, mass of the nucleus and the positive charge of the nucleus is concentrated on a very small space, in a very small space, and that space we called what? That space is called nucleus. That space is called what? Nucleus. Okay, and after this we have done some calculation. So we can say radius of nucleus is around 10 raised to minus 15 meter. 10 raised to minus 15 meter. And where is radius of atom? Radius of atom is of order of 10 raised to minus 10 meter. Okay, radius of atom 10 raised to minus 10 meter, and radius of nucleus 10 raised to 15 meter. There's a difference of 10 raised to 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1 lakh. So radius of nucleus is around 1 lakh time shorter than the atom. 1 lakh गुना छोटा है ये. Radius of atom is 1 lakh time less, shorter than the radius of the atom. Okay. Another thing. Let me drink some Pepsi. Another thing that the deflection, where is the marker? The deflection or the deflected angle theta and theta are different for the different particles. The number of alpha particles deflected at angle theta. We are measuring, let's say for gold, at some angle, say 45 degree, how much atoms are scattering. And let's say we are doing the same experiment for, let's say, platinum foil. So what we are seeing, the number of alpha particles scattered at the same angle for gold and for platinum are different. The number of alpha particles scattered by the gold and the platinum at the same angle are different. So what does it suggest? So what it suggests that different material has different positive charge. Different materials have different positive charge. Positive charge can be different. Positive charge can be different for different particles, for different elements. For gold it is different, for platinum it is different, for silver it is different. For every different particle this number can be different, and this is different. Okay, any doubts? If you have any doubts, you can ask me. If you have any doubts. Okay, I am here only for you. Tarun, Arusha, Krishna, Nidhi, Tanya, I am here for you. If you have any doubts, you can ask me. Another thing that is came that the electrons. Okay, there was a discovery of the electrons by the whom? By the Thomson. There was a discovery of electrons by the Thomson. Thomson discovered the electrons, but Rutherford said that these electrons are attracted, or you can say connected with the nucleus due to the electrostatic force. These electrons on atom, the electron on the atom is connected to the atom by the electrostatic force, and this electrostatic force gives rise to what? Centrifugal force. This electrostatic force, and this is moving in an orbit. So this electrostatic force is giving what? Giving power to the, or giving its energy to the centrifugal force. Okay, or you can say centripetal force. You can say centripetal force in this case, not centrifugal. We will use simple term centripetal force. So this electrostatic force will get converted into the centripetal force, gives rise to the revolution of the electron around the atom. This is the fourth thing. That is came to analysis. What does the Thomson said? Thomson क्या कह रहा था? Thomson कह रहा था कि भैया बात ऐसी है कि ये गोला है, गोले में इलेक्ट्रॉन है, आप पावर आप क्या कहते हैं, थर्मो, आप उसे गर्म करोगे, आप उसमें फोटोन रे डालोगे, वो इलेक्ट्रॉन से निकल जाएगा. और इसने क्या कहा? रदरफोर्ड, व्हाट डज रदरफोर्ड सेड? रदरफोर्ड सेड ऐसा नहीं है मित्रों ऐसा नहीं है. He said, so these electrons are connected due to the electrostatic force, and this electrostatic force is converted in the centrifugal force and gives rise to the revolution of the electrons, gives rise to the centripetal force and gives rise to the revolution around the nucleus. Let's say this is the positive part, okay, and this is our nucleus. This is our nucleus. This is our circular path. This is the circular path, and this is the electron. This is the electrons that is getting attracted. And this electrostatic force is get converted into what? Centripetal force. You can say Fe is equal to Fc. This is the similar case. This is the same case like in the planets revolve around the sun. The gravitational force gives rise to what? Gives rise to the centripetal force. Okay, same model. Gravitational force, the gravitational attraction between the planets and the sun, giving rise to the what? Centripetal force. Similar thing is happening here. Similar thing is happening here. The electrostatic force giving rise to the what? Centripetal force. What is the electric force? K. And you can say Q1 Q2 upon R square is equal to centripetal force mv square by R is equal to mv square by R is equal to mv square by R. Okay, where Q1 is charge on electron, where Q1 is charge on electron, and Q2 is charge on nucleus. Q2 is charge on nucleus. Charge on nucleus. Charge on nucleus. Okay, we can write it like that. We can write it like that. K, this will be E into ZE. So ZE square. Let's say this is a charge ZE. This is the E. So it will become E into ZE. That will ZE square upon R square equal to mv square by R. We can write it like this. AZE square by R square equal to mv square by R, where is the R is the radius of the orbit, where R is the radius of the orbit, where R is the radius of the orbit. Okay. And this thing we will study in more detail in Bohr's atomic model. In Bohr's atomic model, we will study this thing in more detail. Okay, in more detail. In more detail. Now let's see what is the thing happening in a Rutherford experiment. What is happening? What is happening? Let's say this is our nucleus. This is our nucleus. And beam of alpha particles is coming like shish, 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 shish. And this is the electrostatic field. This is the electrostatic field. This is the electrostatic field of what? Of the nucleus. Of the nucleus in which the force due to this nucleus can be experienced. So no change here. No change. Undeflected. And this will come little deflected. Okay, little deflected. And this will be more deflected. Totally deflected. Okay, deflected. And this is the thing that is happening. This is the thing that is happening in the Rutherford experiment. Okay. So this is the distance. This is the distance we talk about. This is the distance that how close an alpha particle can come. This is the distance that how close can a alpha particle can come. Okay. And what this distance called? This distance called as distance of closest approach. Distance of closest approach. How much close can you reach? Okay, how much close can you go to the nucleus? How much close can you go to the nucleus is called as distance of closest approach. Now let's do some calculation and find what this distance is. And we will apply conservation of mechanical energy. What is conservation of mechanical energy? We will apply Ui plus Ki potential energy. plus kinetic energy initial is equal to potential energy final what plus kinetic energy final. Kinetic energy final. We will take two cases. First case here and second case here. Okay. In first case, let's say it is coming from very it is coming from far away. It is coming from far away. Like it is coming from infinity. Okay. So we can write 1 by 4 pi epsilon naught q1. Let's write it k. Let's write it k. Okay. Let's write k. K q1 q2 upon r, and r is here is what? Infinity. What is potential energy? K q1 q2 upon r. Electrostatic potential energy. K q1 q2 upon r. Okay, infinity. If something is getting divided by infinity, what it will become? It will become 0. So this thing becomes 0. Plus kinetic energy, let's write it kinetic energy K E. What is final potential energy? It will be K q1 q2 upon r naught. R naught is this distance. This is the distance R naught. This distance is R naught, and R naught is what? R naught is what? Distance of closest approach. R naught is what? Distance of closest approach. Distance of closest approach. Plus kinetic energy final. What is the kinetic energy final? It is 0. At this instant, the velocity of the particle will become 0. So kinetic energy at this second condition is 0. So this thing cut. So what is R naught? R naught will be if we put the value. So K, this is E, Z square upon R naught. So R naught will be 2 ZE square. Okay. Upon, let's put the value of K, 4 pi epsilon naught into KE. What is Q1? Q1 is what? Q1 is 2E. The charge of the alpha particle. Q2 is ZE. Q1 is 2E. The charge of alpha particle. Q2 is ZE. So it is 2ZE square upon 4 pi epsilon naught KE. Okay. So this is the distance of closest approach. Okay. Got it? If you have any queries, if you have any doubt, any queries, and anything you want to ask me, you can ask me. This is the chance, my students. That you can ask me. Okay. If not, then I am moving forward. Okay. Okay, my dear friends. So distance of closest approach. Okay. It has given us the idea. Of what? Size of the nucleus. It has given us the idea that how much the size of the nucleus actually is. We know that R naught, if we calculate the value of R naught, we can say the radius of the nucleus is going to be shorter than that. And the value of R naught we get is 30 Fermi meter. Okay. R naught is 30 Fermi meter. Fermi is what? Fermi meter means for 1 Fermi meter is 10 raised to minus 15 meter. So it is given us the basic idea that how much the size of the nucleus is. It is in the order of the Fermi meter. It is in the order of Fermi meter. Okay. It is in the order of Fermi meter. So this is R naught and this is R. R naught and R. So it has given us the idea that how much big can be the nucleus of the atom can be. Okay. Okay. Now. What our course looks like. Okay. What our course looks like. What we are offering in our platform. So we have 90 plus classes. We have 90 plus classes, concise and concentrated on what? On the NEET. On the NEET. Concise and concentrated. What more you want? What more you want? Okay. Convenient educational platform. If you have internet, and if you have YouTube, if you have YouTube on your phone, you can access us from anywhere. You just have to install YouTube and you can access us from everywhere. Syllabus made from the NEET experts. Okay. Syllabus has made from the NEET expert by Ishwar sir, by the Pratyaksh, by me, and the other faculties also. And we are the first in India that is introducing flipped classroom method in India. We are the first that is introducing flipped classroom method in India. And if you study by this method, you will have more 50% chance to get enrolled in your dream college. And we have live doubt solving practice method, in which what you have to do. What is actually doubt solving? Just do what? You have fun. Okay, you have fun. Just take a snap. Click. Take a snap and share us with our faculties, our mentors that are in the groups, and they will clear your doubts on the spots. This is what doubt solving practice, live doubt solving, and we also have doubt solving practice. Okay. Another thing, how our class looks like. First, we do the theory. All the theory. कुछ नहीं छोड़ते भैया, हम कुछ नहीं छोड़ते. जो पेपर में आएगा वो तो भैया होगा यहाँ पे. So first we do the theory, all the theory, and after this we will give you study materials. But I prefer you that you will make your own notes to get in physics is what? Physics is mathematics. Physics is mathematics. And what is the mathematics? Which type of mathematics? The mathematics that you have to visualize, that you have to imagine in your brain. Physics is just a mathematics. If you can visualize it, you can do physics very easily. You will do physics very easily, and it will become your one of the favorite subject if you can visualize this thing. And you are the students of the biology. Whose imagination is better than yours. You are imagining the cells. You are doing mitochondria, endoplasma, and reticulum and what not. So physics is mathematics. And after this we have doubt solving webinars. In which you can ask your doubts. If you have something remaining, so we also do that. This webinars are also live. Then we have homeworks. Okay. नहीं करोगे तो पिटोगे भैया. So we have homeworks and we do check them. We do check them, so you can see that how are you progressing, how good are you progressing on the things in homework thing. After this we have 3 hour subscription plans: light, smart and proficient. In light, smart, proficient, what we have? We have interactive live classes, structures course PDF, live test, physical notes. These 4 things you will get in this. Okay, you will also get interactive live sessions in 5 p.m. we will do this. Okay, there are also atoms nucleus class in at the 5 p.m. You get structures course in PDF, you will get live test, you get physical notes. In smart, what we more offer you? We will offer you mentorship. Let's imagine this is the building, Uchiya building. Okay, this is the building of aims. And you want to reach here. There are 2 ways. First way is like this, straight. The first path is like this. Okay, this is the first path. And another path is like this, ding 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 do. Second path is like this. So which path you will prefer, first or second? First and second. So we will teach you how to do hard work. We will teach you how to do hard work smartly. Hard work can, anyone can do hard work. Anyone can do hard work. But there are, but the paper, the toppers, they do hard work smartly. So this is okay. Mohan Reddy, you will take second path. Okay, you will take second path. I will prefer you will take first path, that you walk on the path of what? Make sure you this is the path, this is a paved way that in which the toppers has been walked, and this is the way that we want that you should walk in the first way, in the first path. Second path is long, will take more time. First path is first path. Okay, so this is what mentorship does. And we have live doubt solving. Now sir, what is live doubt solving? I will tell you again. This is a form. And what you have to do, if you are stuck in question, click, do the clicky thing, send us to the mentors that are in the groups. They will solve your doubts. This is the live doubt solving. And we have the mock test for testing the water. How much water you are in. ये कितने पानी में हो आप? Reality check. It is important to have a reality check. So mock test, do the reality check and make sure that you give some. And proficient, we have additional special courses in which you will get some motivation. If you want some motivation, we are there for you. And for the smart course, the regular price is 3299. Is 3299 for what? For the what? For the smart. I am talking about the smart. And if you apply the promo code, what promo code? If you apply the promo code NEET PHY 30, NEET PHY 30, you will save 3,000 rupees. You will save 3,000 rupees. If you apply NEET PHY 30. If you apply NEET PHY, you will save 3,000 rupees. For some, 3,000 rupees is a very big sum. So for the first month, you can save 3000 rupees, and you can get enrolled only and only and only in 299 rupees for the NEET exam. And the NEET exam, is going to be form is going to be released soon, so we will update you on that too. Okay, we will update you on that too, so make sure you are following us. And after this we have two telegram channels. First, for this, okay, you can scan this, take the screenshot, scan this is our main channel. Okay, this is channel, and this is our chat group, and this is our chat group. So if you join this, you can join this in this group. There's also me, there's also Vishwajit sir, there are the mentors, there are all the things. You can have interaction with us if you join this group. Okay, this is a chatting group. You can interact with another students also. You can have the quizzes, you can have the all the things that you want right now. Okay, and this is our channel, so make sure you join them, and see you tomorrow, and we will do the line spectrum of hydrogen atom and the Bohr atomic theory and line hydrogen spectrum tomorrow at 2 p.m. sharp. See you tomorrow. Till then, take care of yourself and sayonara.